Hey everyone, welcome to the stream. So, since last stream I worked on a bunch of stuff, so why don't I just go through a little bit of that. Last stream was the 29th. Here. So what did I do? Map pause button, map pause to, oh yes, map pause to the gamepad start button, and turbo to gamepad right analog. So if you were watching last week, that's what I pretty much ended on. And after that, I actually tweeted about this, I struggled for a little while on stream trying to implement focus toggling between the console and the main window. Turned out it wasn't actually that simple to do, especially because I'm in Windows 10, and it looks like on Windows 10 they basically, and with good reason, made it more difficult to have applications steal focus. However, in my case, since the console window and the main application window are both started from the same, main thread, it's okay for me to do the focus switching, but the way to do it was a bit different from what I used to do. So I actually found some code somewhere online, and it was code written in like vb.net or something, and I just took it and adapted it. So yeah, let's see if there's anything interesting in there in terms of code. Like the main thing that I had to implement is here, the set focus here, and you give it a window handle. Oh yeah, and actually that's actually kind of something fun to share. This is another C++17 thing. Is I at first I was passing in a void star because I have this like platform namespace, and it's supposed to be like platform agnostic, right? So I try to provide an interface that would work for any platform. And so for set focus, I wanted to pass some kind of window handle, whatever that is. And initially I had it as a void star, figuring, that's the most opaque pointer type, I could pass in. However, in C++17, there actually is a type called std_any, which is a really cool type because it's a type that could hold, as the name says, any type. It can hold anything. So what I do is I say my window handle is a std_any, right? And then in the implementation, you can do what's called an anycast, and you can cast it to what, let's say here, an hwnd, because that's the Windows type, right? So I cast that, and this cast would throw if, let's say, I tried to pass something that's not an hwind. So I think that's pretty cool. And then I guess the calling code would be worth taking a look at. Let's see here. Yeah, so the calling code is here. Well, you'll see. So I have this function get main window handle. Now this actually uses an SDL function that is platform agnostic. It's called get window mminfo, which returns this struct. But there are fields inside the struct that depend on which platform you're on. So on Windows, you can access win.window, and this is actually an hwnd. So we're returning that as our std_any type, and so then right there it ends up. In fact, I believe it has like a small memory optimization, but if it's not large enough, it'll have to allocate on the heap. In this case, I'm quite sure it fits because it's just a pointer, and it so it stores that in there, but it stores also, if I recall, it stores the runtime type information, the RTTI, so that the anycast can validate. I'm not actually sure what it does if you disable RTTI. I want to look into that at some point, but not now. In any case, it totally works, and I'm much happier with it because it's definitely more type safe than just passing around void stars and hoping for the best. So anyway, we cast to hwind here, we grab it, and then basically the code from that vb.net link that I found was you have to grab the foreground window thread this way. Actually it's this process ID, and you get the thread ID for the app, and you say if they're not the same. So basically, if the current thread ID is not equal to the process ID of the foreground window, get window thread process ID. Get window thread process ID. I wonder how this could ever be the same actually. I don't know. Anyway, apparently what you're supposed to do is you're supposed to attach your thread input to the foreground thread in case it's not the same as the app thread. So you like temporarily say this thread now has my input. Then you can use bring window to top and then you undo the attachment. Otherwise you can just call bring window to top if it's the same. So anyway, whatever. This code totally worked. And set console focus was, yeah, and then this one here is just to set the focus on the console, which grabs the console window, blah blah blah, and does the same thing. So long story short, what that looks like, so there's this change, and I know that I did another change here called improve focus switching. So I'll show you what it looks like. Yeah, this was an error. Okay, actually I'll show you the next part of the change because I think it's kind of cool. Is this the cool one? Oh, it's not that cool, but what I did here, okay, I won't go through the diffs, but if I run, oh, this may require me to change something in options for streaming. Okay, so let's see if this works. Actually, let me build and release, because in debug it's still too slow, or it's still annoyingly slow, I should say. Okay, so here's the main window, right? I hit Control C and I'm in the debugger, and if I hit continue, I'm back in the main window. So this is the main thing I was going for. But now there's a bit more than that. Like if I step, let's say 10 instructions, you saw like it quickly went to the application and back. So if I make this a bit longer, you see, and it'll run, and then it should, after 10,000 instructions, come back to the debugger. At least it should. Okay, well actually this is another example. So an assertion just occurred, and in this case it's a unhandled op, and it again broke into the debugger. So there's the focus switching again. I can continue. Kind of odd that the step thing didn't work. Let me see. I'm gonna quit again. So let's say I do okay, for some weird reason my Twitch thing reloaded. Okay. I think I'm still, yeah, everything looks okay. So step 100,000. Oh, looks like there's some kind of weird bug here. Okay, that's super odd. Anyhow, okay, that's a bit strange. Take a look at that. Replace trace and color. Oh yeah, so these are some minor things. I fixed the thing where I wanted to have like a toggle command so that I can use T for trace or trace. So now, like in my help here, you have toggle, color, or trace, and T or trace are the same thing. So if I say toggle color, then we have the color. I can say toggle trace, trace disabled. Again, I can go back. So that's the toggle stuff, and then I can write trace or trace. What I like too is I can now like kind of keep this full screen and go back and forth. I don't need to tile them next to each other, so it's really kind of cool that way. So yeah, that's good. Thinking about that weird bug we just saw. So command to, oh yeah, so this is the other thing I wanted to get done, which is kind of important for me for actually making use of the trace, is that I can now, let's say I stop here. So if I say trace, show me the last 10,000 instructions. So there they are. And if I do this, and I say, -F, and I say trace.txt, let's say. It says writing to trace.txt. And now if I go on my Vectrexy root here, I have this file with all the instructions in it, which is awesome because now I can search it and all that. And I can update it, it'll reload. So that's kind of cool. Next. Okay, so this was minor. Fix crash that might occur. Yeah, this was just an initialization bug. Oh yeah, this was allow Control-C to break out of trace printing, as it can be a long operation. So I mean, not a super interesting change, but say I'm printing lots and lots, I can hit Control-C because I might go, oh, I don't want to wait for that because I'm printing 100,000 instructions here, and this can take quite a while, right? Now on its own, that's not exciting, but I thought the way I implemented it was kind of interesting. I'll show you what that is. Basically, I just did another typical C++ Rise solution to the problem. So I have here a scoped console control handler. So the console control handler is what I call the thing when you hit Control-C. And so what I do is basically you can create a new handler, which is actually a templated type. Typically it's going to be a lambda, but it can be any callable. So what I do is I say, before we do anything, let's call get console control handler and store the old handler. And then we call set console control handler to set it to the new one you've passed in. And then in the destructor, we go and set back the old handler. And this is kind of cute, like rather than write explicitly the type of what get console control handler returns, I just do a decal type on it. And this is kind of more flexible, right? Because since it's actually a std function that we bind, I may eventually change that std function to be, instead of like a bool function that takes nothing, maybe it'll take a parameter later on, and I won't have to change the declaration here. In fact, nothing really will have to change here. This will just keep working. I thought that was kind of nice. And then here, this is like, so keeping in mind that we use, we call set control handler. Let me see if I can find it here. In the init of the debugger, we set it right off the top to be a function that says break into debugger. So if I hit Control-C, usually we break into the debugger, and that's what we want. That's the default behavior. That's what allows me, let's say while I'm running here and I hit Control-C, I break right there into the debugger, right? So that's nice. But then when I'm actually doing processing the command for trace, and we say, okay, we're going to be going and tracing and outputting a whole bunch of stuff, right? What I do is I say allow Control-C to break out of printing ops, which can be very long. And so I just have this little bool, keep printing, and I create a scoped console control handler. And here's the body of that handler. It says, I capture the keep printing here. I set it to false, and I return true. So should Control-C get captured here, then I want to set keep printing to false. And then I go into my loop here, and I just have this loop that prints out every single trace info, and I keep checking. If not keep printing, we break. So if I hit Control-C now during the print, it'll trap into here, set this to false, come out, and then this will be true and will break out. And then when we fall out of scope, the scope console control handler resets back the control C to the previous control handler, which is the one that just allows us to break into the debugger. So just another, typical usage of C++ RI, but it's something that this is like one of the things I love the most about C++. So yeah, like I was saying, if I hit Control C and then start printing, now there's a new control handler that's in play, and when I hit Control C there, it breaks this, and now we're back to the normal Control C. So that's kind of cool. And yeah, that's pretty much it. There's the trace file here. So that's all there is in terms of what I've worked on since last stream. So that's pretty cool. There is another thing here. You can see there's a branch over here. I started looking a little bit at basically, I'm not sure if I want to do this, but I wanted to look at whether or not I could do better handling of my debugger command parsing. Like right now I have a very basic, very straightforward inline parser that just checks like if the token is, the 0th token here is quit or Q or help or H, right? I have all of these here, and then it gets a little bit wordy and annoying for when there's more than one, and I have to set valid command equals true equals false and all that. Not super awesome, but still pretty straightforward, right? But I just thought maybe I could do better, right? Like if I make use of, I thought maybe if I make use of a command line argument parsing library or something, I can maybe use that and simplify this code. So I looked into it online, and one of the ones that was recommended was CXX ops. So I started messing a bit around with that. I have to be honest, I'm not super impressed with it. I don't think it's a bad library by any measure. I just don't think it fits what I'm looking for, and it has a couple of things that I find a bit weird. So I'm not sure that's the way I'm gonna go. And there's another one that I heard about, which was I actually had it open on my phone. Let me take a look. Yeah, T-clap. This one here, the templatized C++ command line parser library. So this one is apparently inspired by the user-friendly clap library. I don't know this project. Apparently also a C++ package, but this one here is templatized and all in a single header. I looked a little bit at it, and I must say it looks pretty nice. I think it actually might be better than CXX args for me, or CXX ops for me. So I might look into this. So it's like the idea behind these libraries though is really to parse, argc and argv that comes out of main. So they have a different they're solving a slightly different problem than what I'm solving. I'm not parsing args to main, I'm parsing args to my debugger. It's similar, but not exactly the same. So, there's a couple things there, like the way it will print out usage and stuff like that, which maybe doesn't fit what I'm looking for. So there's another alternative to this, which is to look at like more general parser libraries, right? So like stuff that, general text file parsing or language parsing, programming language parsing libraries. One of the things I was looking a little bit at was, what do you call them, like parser combinators. So C++ parser combinator. So there's a few of them. So like this one here is an example of one. It's a C++ parser combinator library, right? So these here are more generic and would allow me to define my grammar and my language a bit more, with a bit more control than typical just command line parsing. Like command line parsing is really a subset of what I could do with a parser combinator. But at the same time, it's a bit more complicated, and I don't know if I need that. So the other final thought I had was I can just refactor this code and just create a couple of functions to make this a bit more readable. Like one of the patterns, obviously one of the patterns I have is, you know, that a token may be quit or queue. So this I could easily make a function, right, to check if it's one or the other kind of thing, you know. So that would be dead simple to fix and make this look a little bit cleaner. But the more common thing that I have to keep checking for is, did you pass a token? And if so, give it to me, right? So that kind of thing I think I can fit into some kind of helper function, and will clean up this code a little bit. And also one of the things I'm thinking about is, so for the trace command, I think this is not right now probably my most complex command. Yeah, definitely is the most complex. You see it starts up here and like ends all the way down here, which is definitely the longest command that I have right now. And that's because you can type trace, and then you may pass -n with a number of lines, or you may pass -f with a file. So right there I have more than one parameter. So that's why this is a bit more complicated. And actually I have a bit of a problem now where, what is it again? -n, number of lines. What was it again that I couldn't do with this? String and then -f. I can't remember. There was something I couldn't do correctly. I mean, I think I can do, I think the way I wrote it should allow me to do it in any order. So like, no, you see that didn't work. -f trace.text and -n 100 for some reason did not work. Why not? Oh, because I didn't actually write trace. Okay, so that works. I don't know what it is. There was something that I couldn't do. Anyway, it might come to me. So anyway, we'll see. We'll see how this goes. I want to add, I would like to add the trace query feature I might have spoken about last stream, which is the ability to run queries against a trace. And that too is going to be a more complex parsing scenario. So that's also why I was thinking a bit about using a library to help me, maybe with a grammar or something. Like another one of the problems I have is like I don't really have great error messages for when you don't do something right, you know? Like for example, if I did -f trace and then -n, we just get invalid command. And I would like to say, you know, -n expected int argument or something like that. That's the kind of thing you get from a library where you define your grammar and you say, I expect you to pass this, and you know, so. And also I would love to be able to do like, give me the help usage for the subcommand. You know, the trace is a sub command, and I would like to see more in-depth help for just the trace command. So anyway, that's guys, I guess just, you know, usage stuff, but it's kind of cute, right? So I think that pretty much covers that. Before we get started, I do want to take a look at why the trace with 1,000 wasn't working. That was super odd. Why I couldn't, what was it again? I couldn't break. So if I did step -n like 999, no problem. 1,000, no problem. 9999, no problem. But then oh no, sorry, it wasn't step, it was trace, right? No, it wasn't trace. I guess it was step. Why is this working now? it was step, but maybe in debug, maybe it's an uninitialized variable problem. Let's try in because I was running in release, so let's see if I can repro it in release. So step dash n 10,000. Yeah, that's the one, right? Where okay, that's it. 1,000, no. 999, yes. So let's see why. It's interesting though. It doesn't happen when I'm in debug. Let's see if I can debug this. So I'm getting number instructions to execute. Yeah, this is not helping me at all. I wonder if I can. I think I can't. I was gonna say I wonder if I can like, given a, I could try it here on a lambda. Can I disable optimizations only on a lambda function? Optimize off. And optimize on. Let's see. Normally I can only decorate a real function with this, so I don't know if this is gonna work. Yeah, pragma must be outside of function. I think that if I move this outside of the function update here, so I can remain in release, it might actually hide the bug as well. Take a look. So step dash n 999. Okay, so still it does happen. That's good. And if I say like this, right there is the problem. You see, I got this huge number back from string to integral. For tokens of 1. Oh. Right. Why am I doing dash n for this? I'm getting confused because trace takes dash n. See, again, error handling is terrible, right? String to integral should probably throw if what I passed in isn't actually an integral. Can I know if this failed? I don't know if there's a way for me to easily know. Anyway, basically what I would need to do is like this, step 10,000. Why am I doing -1? Oh, because I've already executed 1 here. Right. So I execute 1 and then I execute n-1 more. Yeah. So yeah, basically that's it. I don't have good error handling. I'm not handling things properly, and that comes back to what I was saying earlier. If I had a better parsing library, I would do that. So Okay, so I don't have anything to fix per se. Printed some music sheets. Okay, close this. Let's take a look at stuff that I want to work on. So for today, I was thinking of doing, I wrote down a couple things. So some of the things I'm thinking of working on. So going back to the glow effect for the vector display, one of the things I was thinking about, because I've been saying about, you know, implementing a blur, but in fact, I'm not sure how well that's going to work. And I'll tell you why. If I open, say, Paint or something, here's what I'm thinking. Like right now, what we're doing is we're drawing lines of exactly like width 1, effectively, right? So if I choose white, and it's like a line draw. Anyway, like we're drawing stuff like this, you know, like very kind of very single thickness lines, 1 pixel wide, 1 pixel thick. And I think that when you take something like this and you blur it, I don't think it's going to come out really nice. Like I'm going to lose the nice clear white line, and I'm just going to get some kind of gray mess, you know? So basically what I'm saying is, what I think I need really is to make thicker lines and then blur them. Yeah, I can't really do blurring here. Do I have Paint.net? No, I don't. I have Paint 3D from Microsoft. Isn't it the Windows 10 Paint? Does this thing do any kind of blurring and stuff? Effects? Yeah, I don't know. Maybe not the time to figure it out. But yeah, so that's it. Just thinking a little bit about it is, if I don't have a thicker line when I draw it, I think we're just gonna like get a kind of gray mess when we try to blur it with the pixels around it, which are black, right? So I'm not really an expert on this, but that's sort of what I was thinking. So I was thinking, okay, so why don't I implement line width? So, you know, in fixed pipeline OpenGL, in the old days, you could set a line width in OpenGL, but with modern pipelines, it is not supported. You actually have to do it yourself. And the way to do that is, rather than draw a GL line, is you say, I can say, we go back to here, this line here, is we know the line, like the start point and the end point, and what we do is we turn that into a quad. So to do that is we take the end point, we take the direction vector from here, take another color. So let's say it was starting here, so we take our direction vector, and we say, okay, and we know that in my case it's really simple, like Z is either towards me or away from me, so we can do a cross product to get an orthogonal vector. And then with that, we know with a little bit of math, we can just add an offset here, do this and add the negative offset here, and we end up with these 2 points. And then we do the same thing at the other end. We use the same thing to get the same offsets here and here, and now we have our 4 points, and we can make a quad, right? So 2 triangles. So I was thinking, like, with that, we'd be able to draw a thicker line. Now, one thing about this is, and I realized this when I was thinking about it, is that we're going to end up with these really hard edges like this, you know? So if we draw, let's say, another line downwards, it's going to look like this, you know? Well, maybe not quite like that. Try and do this a bit better. So, no, oh, there's a line. Okay. And white and thin. There. Let's say we draw something like this, and then we make our thick line. It's going to end up doing something like, so we take red. Oh, sorry, this was supposed to be white. Now red. Oh, okay, that's why it changed. Red, okay. And then we're going to end up with something like this. I mean, I'm exaggerating a little bit here. Obviously, my lines wouldn't be this thick, but still. kind of makes the point, right? And we're gonna end up with these like chunky triangles in there. So yeah, and I was thinking, and I think I saw something online about, you know, how to solve that kind of problem. Why can't I choose this color? Paint drives me crazy. Color 1, color 2, black. Okay. No, I can't even see it. Try and make this a little bit cleaner. So okay, something like that. Or something like this. So yeah, and then I was thinking about this and looking at it, and it's like there was some stuff about, well, if you know your lines are connecting, you can try to do something at these corners here so that they actually connect. And it's a bit more complicated in that case. You know, I think that's what vector drawing applications do is instead of just drawing, let's say, simple quads, what you do is you create a triangle strip. And so here you'd say, like, actually, when we go from here to here, we're going to draw another kind of triangle that connects this here, and another triangle that connects the other spaces or something, and like from here to here, and yeah, that's it. And then after that, you know, it kind of gives a more rounded edge, and it looks like it all connects together. I'm not going to go that far. I think I'm going to start with a simple quad approach and just not make the lines too thick. And then the idea is that if it's not too thick, then I think that with that and some blurring, we may be able to hide the fact that it looks that way. That's what I'm hoping anyway, right? Because ultimately we're trying to draw vectors and a vector display. So now as for blurring, I was thinking about, you know, initially doing the blur in the shader, like writing a shader that does some kind of blur, something I've never done before, but I looked a little bit into it. It looks, you know, reasonably easy to do. But then I was thinking maybe I could just try doing a simple blur just as a test by rendering to a larger texture and scaling it down with a linear filter. You know, so, you know, maybe drawing in a texture that's twice the size of the Vectrex display. So the Vectrex display is 300 by 300. We render to a 600 by 600 and then scale it down to 300 by 300 with a linear filter. And then that actually will get blown up. But just the fact that we downscale it, we kind of take advantage of the built-in linear filtering of the hardware. So that actually might give us enough of what we want, you know? So yeah, that's sort of what I'm thinking. Actually, it would be kind of interesting to just try as an example. No, not that. Paint.net. Let me try and download this. Oh, you can even get on the Windows Store paid? This is like one of the worst things to download. How do I download this? Oh, there we go. 18 clicks later. Don't know why it's taking so long, but Oh, okay, it's because I Windows was trying to get thing running, and then I had like 3 launches of it. So again, so that's while we do that. The other thing I thought about working on was those trace queries. So this would kind of be continuing the effort on making the debugger better, always with the intention of fixing all those ROMs that just don't work, you know. So I mean, there's the obvious things of instructions that have not been implemented yet, like what we just got there. That was like a long branch something that we could just implement. But there are some more difficult bugs to fix that I want to use my trace for. Alright, so here's paint.net. So let's see if we can try what I was trying to say. So let's say we have a 300 by 300 display, right? Like this. And we want to first, let's bucket F, make this black. And then we want to draw some white lines. Okay, so this already has some anti-aliasing that's being applied to it, which I would like to remove. There we go. So this looks like the kind of lines that we're drawing. So let's say we just take this, right? And I guess actually what I should have done is started with a 600 by 600. So let's say we were to actually render these in 600 by 600 instead. Okay, so no aliasing there. And then we were to change the canvas, resize to 300 by 300. And we say bilinear. So this should be an approximation of what we would get with OpenGL. Yeah, so see, this is what I was afraid of. See, when we do that, if I can go back and forth, you can see that basically what we do is we've lost the color. It's gone from white to gray. So that's basically what I'm afraid of. And it makes sense, right? Because it's going to end up just downsampling. And I think that's the same thing that's going to happen with a blur. So instead, if we were to make these quads, can I do that here? Draw can I do shapes that have direction? Yeah, we could do that. So let's say we did a really long line like this. How can I say that I want it filled? Okay, rectangle, yeah. Brush with fill with a solid color. I think it fills with a secondary color. No? Okay, here, draw filled shape. So let's say so if we have, let's say, a instead of 1, 2, say triple thickness line like that, and let's draw another one, but we'll rotate it a bit. I think we can do that here. Oh, there we go. Okay, so here we have 3 lines that have a thickness of 3, or width of 3. And now, if we were to resize the canvas to 300 by 300 using bilinear, yeah, see? So now we get a bit. So we keep the white in the center, which makes sense. We get gray on the outside. But I don't know if that's the effect I want. That's not really a glow. That's just a, I suppose that's what a blur is. So this is not really giving me the kind of glow effect that I was hoping for. Because really what I would love is to have, you know, the kind of Vectrex glow. You know, you can kind of see, I mean, these are terrible quality, I guess, but you see there's like this kind of inherent glow coming out here. So I mean, for sure the thickness is going to help. Even if I don't do the downsampling, just drawing lines thicker will be a good start. So I can definitely start with that. And then after that, what effect we apply to the thicker lines, I think, you know, that'll, you know, we can try to come up with something. But definitely having the thicker lines is a big first step, I believe. So we could try that. I also read that, like, you know, one way to make one really efficient way to turn lines into quads would be to do it with a geometry shader. But that, you know, requires more modern cards, and yeah, I just feel like maybe I should stick to GLSL 3 instead of, I think it's 4.5 for geometry shaders. So anyway, if any of you watching have ideas on how I could do this kind of glow effect, or what the best way to do this is, because I'm really not a graphics guy, so I'm really learning as I go. But if any of you who are watching have some thoughts on this, feel free to share. Share on Twitter or here on chat, whatever. I'm totally open to suggestions on this. All right, so let's try and do this quad thing and see what happens. Danny Fritz, hey Danny Fritz. Danny Fritz says a convolution matrix, I think, should be able to do a glow. Convolution matrix. Convolution matrix. Or let's say, what should I look up? GLSL, OpenGL. Or maybe just convolution matrix to start. So I'm not quite sure how, I don't know much about this, so if you have like a more direct link on what that means and how I could use it. Oh, okay, I see what you mean. Where you oh yes, right, where you define the effect that you're going for. So you're saying I could like say like what to do with the pixels. So I can say I want 1 in the middle, but I want, let's say, 0.7, 0.5 type of thing, and so I can define, let's say, the spread of my pixels and the blend. I suppose that's what you're suggesting. A Gaussian blur is a particular convolution matrix. Right. Increasing symmetrically as distance from the center increases, right? Okay, so yeah, that makes sense. So I guess I could implement that. And do you think that starting with having thicker lines would still be a good first step in this in the right direction, or should I just stick to the single lines that I have and apply this kind of Gaussian blur and I get pretty much what I want? Because right now there, you can see that it's very thin, right? Like if I just run this and I'll hide the overlay. Like these are, if I take a screenshot. I'll open it in Paint. These are really single lines, right? Anyways. I would do single lines and put a Gaussian blur behind it. That's what Danny Fritz suggests. So not bother with the making thicker lines. Just to see what it gives, I suppose. I mean, I guess that makes sense what you're saying, right? Because if I can control the blur, I can keep the white that I want, and I can even spread the white. I guess I can make my lines thicker by just putting ones in the matrix all around and then decreasing it afterwards, and that would give me a very bright center. I wonder if the example that I downloaded, what was it again? In here. Okay, so I think I read about this, that the way to implement these kind of blurs is to do it into two passes, like one vertical and one horizontal. curious why he says to create frame buffer objects that are larger than the display. Sorry if it's a bit more boring to watch me read, but I don't know how to do this, so I'm just going to read a little bit about it and try to implement it. Okay, so here's where the magic occurs. Those are the three uniforms that he's going to use to do the blur. So here he's not actually using a Gaussian matrix, right? He's just actually doing some kind of just computing I guess a smaller value for the sampling of the texels. How far off center to sample from? 1 blur by 1 pixel, 2 blur by 2 pixels, etc. So radius divided by resolution. Okay. The direction of our blur. Oh, okay, here's the Gaussian. 9-tap filter with predefined Gaussian weights. Okay, so there it is. I see, okay. Alright, that makes sense. X minus this. I suppose it's a little bit wasteful that when you set, let's say, 0 for one of the axes, we're doing this multiply by 0 just to get back the original y. let's say for when it's 0 here, and then the next time around this part is wasteful. But I suppose it keeps the thing simple, and if it's not too much of a problem. Otherwise, I guess it's 2 different shaders to avoid these useless multiplies. Just wanted to see how similar these numbers are. No, they're not that similar to this one here. Well, somewhat. 0.05, like this in here. Suppose the 0.11 is similar to this. Not sure where the 0.19 is from, but I guess you could put whatever you want. And I suppose I could, if I wanted to, I could pass a matrix in with these values. Or maybe not a matrix, but just like a simple texture with these, like a 1D texture with 1, 2, 3, 4, 5 values, and then we could play with them. I wonder though, like, how much I'm gonna get out of doing like this 9-tap filter, let's say, right? I mean, in our case, it's mostly a black screen with white lines around it. Anyways, I guess we'll see. I guess that makes sense. Doing it in 2 passes is an optimization. Otherwise, you'd have to sample all of these texels in 1 pass, rather than just one like this and then along the lines here. It's pretty smart. Oh, that makes sense. So here it's saying this is the reason why the texture has to be larger than the screen. Is because you want to be able to see the blur effect even on the edges. Otherwise, it would cut it off near the edges. There'd be a harsh cutoff. All right. Danny Fritz says, the size of the array is the size of the potential glow. It could only blur 4 pixels out if it only looks 4 pixels out. Yeah. Yeah, that makes sense. Yeah, okay, I see what you mean. Okay, that's in response to what I was saying about how large it should be, right? Yeah, okay, you're right. That totally makes sense. If I want the glow to be thicker, that's how large the matrix needs to be, right? So 9 point means that we get 3 pixels on every side, and that's like 9 pixel glow, let's say, for 1 pixel. Yeah, that makes sense. Okay, I think 9 will probably be fine, especially given that like we're working with a 300 by 300 display here. So I'm just gonna go remind myself a little bit the structure of the rendering code. Alright, so first we render the game stuff to this texture here. And this is the one that we darken. So between this and the darken pass, I'm gonna want to do the blur, and then we want to darken. So definitely it's gonna come between pass 1 and pass 2 right now. Yeah, so what I'm gonna do is I'm gonna do a, no, not here, but we'll introduce a texture resource here. We'll call this glow texture. Now for this, I'm gonna, for now, just make it the same size as these ones, despite the fact that I should make it larger. I just want to see what it looks like. And then I'll worry a bit, because there's a bit of annoying math that I have to do for this right now. So I'm just gonna keep it like this for now. Okay, so let's do this. I'm going to need to write my program for this. We'll call this okay, so I'll call it apply glow or something. Or just glow. Then we'll do, yeah, so I'm gonna need to bind yeah, curve texture 0, that's correct. I'll call this I don't know, input texture. We'll set our uniforms. Resolution and radius. Trying to understand this code I wrote. So I have these UVs here, and the UV buffer, attribute buffer UVs. Why did I need this again? pass through and darken. Okay. Because we have to pass it the UV, which is, no, we don't have to pass it here. Yeah, we do pass the, okay, we pass the UV here, we set it there, and then darken ends up getting it here. Okay. Right, okay. So I'm going to need the same thing here. I mean, it's basically the same thing as what I do for darken. So yeah, this would make sense. We'll do one direction and then we'll do the other one if this works. Okay. So a little bit different. So this one here, I think I called it input texture. And we'll want some other uniforms here. just going to copy this. Can't do anything with this. Alright. Okay. Now, assuming this works, I need to set these values before we draw. It's GL set uniform, I think. What was it again? Just GL uniform. So the direction was a Vec2D. And resolution, that's the size, right? That was a float. Oh yeah, I didn't make sure that it's square in this case. And we're using resolution, radius of resolution. Do I really need to pass both of these here? Just gonna pass in. We'll start with that. Let's see what that looks like. So if this works, we end up with the thing in the glow. Before I continue, actually, I think I'm just going to see if this actually even compiles and runs. And I can use RenderDoc if this works to take a look at what that texture looks like. View texture. be color. Okay, so now no errors coming from the shader. Let's run with RenderDoc and see what we get. Alright, how do we give it the path? Capture a frame. Oh yeah, one thing I didn't do was actually name. You know what? Let me do that before I continue. So by giving it an object label, the texture, we will be able to see its name in RenderDoc. Okay, so this is apparently our glow texture. Interesting. Not exactly what I was expecting, but at least it's not complete garbage. It's as though what actually applied was the darken. Let me see if it actually ran that shader. Input texture is current. I mean, the fact that it says input texture here. Use program. Bind texture. Yeah, so I'm not quite sure why this looks the way it does here. It's not the same as a darkening. This is the darken from... The darken is much softer. There definitely is... It is doing something, the blur, but it's not doing what I was hoping. And maybe it's just the way... we're feeding it values here. And then normally what I would do now is copy it back to, well no, actually I would do blur in the other direction and then copy it back to the current texture 0. Let's do the copy back and just see, because then we could play with the values a bit at runtime. Copy glow texture back to cur. I really need to change these names. Cur rendered texture 0 doesn't mean anything, but anyway. How do I copy it back? Okay, I'm realizing that I shouldn't be doing a copy back, but really what I should be doing is I have these 3 textures and I need to be playing with which one is the current. You know, I'll be swapping between 0 and 1 and the glow. But just to keep it simple for now, I'm going to do a copy and look into optimizing that if I really need to. So we want to render back to texture 0, which is what we just made glow. We're going to set the input. Oh no, okay, this is wrong. Oh, interesting. Right. Yeah, that's not right. Okay, that might explain why this wasn't working in the first place. Copy paste. It's always the same, eh? Let's see if this works. Okay, undeclared identifier rendered texture. This is in copy texture. Yeah, okay. Hey, check that out. We have blur. In one direction right now, but that's still pretty cool. So let's add some sliders to just mess around a little bit with these parameters. Just want to see what it looks like. Glow radius will be this. And we'll do this. I mean, I don't have to really play with resolution. In the end, it's just a ratio that we're playing with. I think I might just forget passing in both and just pass in like a glow factor. Oh, and it doesn't need to be 0 to 10. So let's check this out. Okay, cool. So let's yeah, maybe 0 to 10 would have been better. Now I think about it. But I'm gonna do now the opposite direction. It's really cool to see how it works. Mia, put back Mindstorm. Yeah, it totally already looks better. It's gonna look even better when we blur it in the other direction. Yeah, Yeah, this code that I keep copy pasting is driving me nuts. It's like everywhere. I need to do something about that. This could be like draw full screen quad. Danny Fritz says, dang, that is a cool emulator. Hey, thanks, man. Is there something specific that you find cool? I'm wondering where else I can use this. I think I can use it right here as well. It's always the same thing, right? Because even when I darken, I just need to draw full screen quad. I think it's the same here, isn't it? Yeah. Maybe not, right? Make clip space quad. I think the only difference here is the fact that we're passing scale values here, so I can make those input parameters because the rest is the same. Yeah, that's the only difference. Beautiful. I really copy pasted that many times. But you know, when you're developing it. Now let's see if I broke everything. Nope, still works. It's interesting actually, because the darken effect is doing something. Oh, it's introducing a form of feedback. Now that I think about it, maybe the glow should be after we darken. That makes sense. Although I don't think it's gonna make a difference because we keep feeding back anyway. So what I'm thinking about is how we draw, we glow, and then we darken, and then the next time around, that's the input to the glow function again. And so what we're doing is we're applying glow on previously darkened pixels. No, I think that's okay. I think it's okay. It's because I'm noticing there's like kind of like almost like a jitter effect. That's what I'm wondering about. I'm gonna remove all this excess code here. Okay, what I'm gonna do, I'm gonna just try it one more time with render doc, and I wanna do a capture, and I just wanna see what it looks like in render doc. I'll open the last one first. See what this one looks like. Yeah. Yeah, there is that's it. Right here I can see it. The feedback problem is that we're drawing to a texture that's already been glowed. That's not what we want to do. We want to just glow for the output, but not have it feed back in. Okay, in that case, just want to see. I think what I want to do then is draw it to here to render to 0. We want to darken it into 1. Then we want to glow it, so that when we render it, and then we render the glow instead, and we don't do a copy back. Yeah, let's try that. No, that did not work. So we use texture 0 to texture 1 here, and then we darken it. Then we take 0, we glow it into, oh right, yes, I know why this didn't work. I guess we could copy it back, but this actually won't be as useful anymore to copy it back. We could even get rid of it, but let's just see what happens. Okay. Oh, sorry, it's this one. See, this is better. I'm gonna do this here. You see, it's much more stable now. It doesn't have that weird kind of jittery effect that we were having before. Try that again. Just gonna give my radius a bit more fine control here. I also want to play a lot more with the kernel, the values that we're putting in that matrix. Right now they're hard coded in the shader, but like this is not enough glow for me. I definitely want a stronger glow than this. Of course, we're not doing it in both directions just yet, so I'll wait until I have that. Okay, so let me just try a render dock capture just to make sure this looks the way I expect. Oh wait, that's not the right capture. Okay. Yeah, so you see now we have this is what I was expecting. We have a clear picture. Then we darken it into texture 1. Then we apply the blur to texture 0 actually. And then that's what ends up getting rendered. But then the next pass, texture 1 is what becomes what is swapped to texture 0, and we end up with a clear image again to draw on. So basically glow is just something that's on the output, and that makes sense. It's an effect on the screen, on the CRT, right? So that's what I wanted. Okay. Can just use Alright, so let's do the glow now in the other direction. I mean, I think it's as simple as this, right? No, of course not. It's not as simple as that. Yeah. I need to go to another texture, of course. Getting tired now. So. Okay, so let's go from this to there. Okay, this is what we're gonna do. We can get rid of this copy actually. And we'll do like this. No. Like this is the input texture. This input to that. And then it'll be the other way around. And we need to change the vector. Okay, so we call glow and we say first we're going to go from the cur render texture 0, which contains the initial image, to the glow texture in the the horizontal direction, and then we go back from now the glow texture to cur render texture 0, but this time applying it in the vertical direction. And now we don't need to copy back because cur render texture 0 contains the final image we want anyway, which then gets used in pass 3. Let's see what this looks like. Let's see if it compiles. Oh, right, I actually should pass in the direction. dir.x and dir.y. Okay, so this is the output texture, and this is the input texture. Moment of truth. Aha! Oh, and I have 2 glow radiuses. That's kind of cool, actually, that we have 2 glow radiuses, one for each call. Okay, but they're controlled at the same time. That's because it's the same static variable. Is this working? Well, first things first, I'm gonna yank this guy out. Let's try within render doc. Okay, that's the darken pass. Okay, so that's the first glow texture. So this looks like a horizontal blur that's being applied, and then the next one should be, yeah. Yeah, so I mean, I think it's doing the right thing. Definitely we're gonna be tweaking those glow values. Because really in this case we've got black and white values, right? So this is the kind of effect we get with like those kind of Gaussian blur values are good for very high color normal pictures, but here it just gives us a very kind of gray and boring looking thing, so not much of a glow effect. Danny Frith says, I would re-render the scene on top of the glow. That's an interesting idea, actually. It's a very interesting idea. But I mean, I do wonder, right, if I play... Yeah, like the white parts. Yeah, I hear you. So like we get the hard center white lines. But I mean, shouldn't I be able to get that anyway with the way we define the Gaussian blur? The only thing is to re-render, then I need to worry about like playing with alpha and blending it correctly and all that. I feel like trying to just play a little bit with Danny Fritz says, I don't think so. It will always sample from black areas and make gray. But isn't there a... Let me see. I think you're right there. But like here, yeah, like what if this was just one, you know? Oh, check that out. Now that's some pretty good glow. Yeah, I think with a little bit more tweaking we can come up with something pretty nice. This is a little bit stronger, perhaps. It's pretty nice, right? Like if we put back the overlay, it's starting to look a lot more Vectrexy. Like maybe I'll put the darken speed a bit faster. What I'd like to do is I'd like to pass in percentages, you know, these values here, there, and then we can play with them a little bit. This is just multiplying everything by 2. Maybe a bit too much though. Hey Benjamin. Yeah, shader tweaking. Messing around with this new glow effect. Yeah, Benjamin says, might be cool to get a screen grab of an actual Vectrex screen to match to. That's true. The truth is, it's kind of tough to get a good screen grab, because, like, they're all, well, like, this is totally exaggerating the effect. Yeah, I didn't think about this. This kind of effect, of course, adds trails. Yeah, because it's like a CRT, and most cameras don't capture the look very well. So I mean, I would have to just look at my real Vectrex to try and see how my eyes see it when I look at it. It's a V slider. Oh, a vector slider, okay. Trying to think what's the right way to tweak this, you know? Give me a second. Just rolled over my headphone wire. Up. Oh, right. Let's see what this looks like. Okay. So now, if I want to pass these in, normally I would want to use a texture with these values in it, but I'm going to be a bit lazy and just use uniforms. Unless GLSL 3 supports passing in like vectors. I mean, apart from textures being treated like vectors. Array of uniforms. Can we declare array of uniforms? Oh, okay. Well, that's better. One VF, no, one FV. Then the size, and then okay. Okay, now we should be able to use these values here. Let's just see if even passing the first one works. Okay, yeah, that works. That's cool. Alright, so now we should be able to tweak a whole bunch of stuff here. Whoa, okay. Yeah, I did not quite get that. I do need unique names, it seems. Danny Fritz says that's a cool debug interface. So that's Dear ImGUI. I don't know if you know what that is, but it's a really cool project. It's basically a C++, but I say C++, but it actually has bindings to a whole bunch of languages there. It's a immediate mode GUI library. But it has bindings for all of these languages here. And it's like basically super easy to use, as you can see. That's the whole point there for the immediate mode, is that you just, in the middle of your code, you just say, I'm gonna add a slider float here with this name, and then it just shows up. And then you can start tweaking it. Yeah, Benjamin says, yeah, Dear ImGUI is awesome. I agree. This is actually the first project where I use it, but yeah, it's awesome. Is it I to S? I forget. To string, from string. That's it. All right. You know what I'm gonna do? I'm gonna do this. I'm gonna use my what's it called again? There we go. Okay, so now we should see separate values. Hopefully we can tweak them. Clearly that's much too high. Oops. Yeah, I don't know. I don't know. I don't know what... I'm gonna have to play around with this quite a bit, I think. Just try one thing. Yeah, I'm kind of realizing that the resolution makes a difference here, because it changes when I resize the window. Size on. Let's see if this makes it cleaner. Yeah, I think this is already better. Man, my frame rate's really taking a hit. Yeah, I don't know. I'm not like super happy with the effect. I'm not sure why. It just doesn't look great, you know? And there's like too much glowing. I mean, not glowing. Too many trails that are being produced as a result. What I'm noticing is that like there's like actually a performance hit when I reduce the glow radius, so that basically is it really? No, not really. Well, not sure. I'm gonna play with this a little bit on my own time, see if I can get it to look the way I think it should look. It's not far, and I mean it is a bit better. I'm still wondering about whether I should be drawing thicker lines to begin with, and what that would look like. And then of course there's also Danny Fritz's idea of trying to maybe just, instead of like messing around with these values here to get the white center, but just kind of doing another pass of drawing the original frame on top of a glowed version, so that we get the centering white and then we get a little glow effect around it. Because if I do that, I could totally exaggerate the glow, right? I could do this, but then have a thick, you know, a nice clear white line in between, and maybe that's really what I should be doing. That probably is what I should be doing. Like I'm trying to achieve what I want without doing that, and it's just kind of messing up the glow itself. I think this is a glow right here, right? This is pretty nice. The only problem is that I don't see the ship and the things clearly anymore, but I get the haloing effect that I want, I think. So Danny Fritz, I think you might be right, and so I think I might try your idea. So to do that, it means I need to have an alpha channel, and do I need that? Okay, well, I'll think about it. Alright, well, I'm gonna leave it like this for now, and I'm gonna think, and I should be back online in a couple nights. So that's Wednesday night, and we'll improve on this. So maybe we'll do the thing of drawing the lines, like doing another pass and draw the lines within the glow and see what that looks like. Hopefully that will give us the effect I'm going for. So guys, thanks for watching, and yeah, hope to see you guys next time. Take it easy.